What we're going to do now is we're going to finish up the notes for D, E, and F on the first example, and then C and D on the second example. So remember, for example 1, what we're going to be doing is we're going to be expanding the logarithms. When we expand the logarithms, what we're going to do is we're going to keep the same base. So we're going to do log of 1/2. Then we have a 5. Then what we're going to do is we're going to put a plus. Remember, because of multiplication, whenever it's multiplying, what we do is we add. Then we do log of 1/2 x. Remember that when we have an exponent, what we do is we bring it to the front. So now what we have is we have a 7 in front of the log of 1/2 of x. Now looking at letter E, we're going to do the same thing. Notice that we have a log base 3. So we're going to do log base 3. This time what we have is another 5 right here. So we're going to put 5. We're going to put a plus sign because what's happening is multiplication right here. We're going to do log base 3 of x. Once again, x has an exponent of 5, so we're bringing the 5 to the front. This time what we see is we see a division bar, and that means we're subtracting. What we're doing is we're subtracting log base 3. This time it's y. Notice that y has an exponent of 5, so what we're going to do is we're going to bring the 5 to the front. Now, if we're looking at letter F, it's natural log again. Once again, natural log follows the same rule as log. We're going to do natural log of 10. Because there's multiplication, we're going to put a plus sign. We're going to do natural log of x. Because it's a cube root, what we're going to do is we're going to put a 1/3. And then what we're going to do is we're going to put a plus natural log of y. We have an exponent of 2. We have a root of 3, so that would be 2/3. And that, once again, is how we expand the logs. Now what we're going to do is we're going to look at taking the logs and writing them as a single exponent. So we see a natural log for each one of these. So what we're going to do is we're going to put a natural log. We're going to look at the positive numbers. We have a 3, so we're going to put a 3. 3 is to the 4th power. We have a x. That's also to the 4th power. We see a subtraction sign and a subtraction sign. That means they're going to be in the denominator. We have 27 to the 1/3. And we have x to the 1/2. We're going to simplify this. 3 to the 4th is 81. The 27 to the 1/3 is 3. We have x to the 4th, and then we have x to the 1/2. What we're going to do is we're going to subtract the exponents. Before we do that, we're going to take the 81 and divide it by 3, and that gives us 27. And when we subtract the exponents, that right there gives us 3.5. 4 minus 1/2. And if we write that as an improper fraction, what we get is 7/2. And that right there gives us our answer. Now, if we're looking at letter D, what we notice is that they're all log base 3. So we're going to put our log base 3. What we have is a positive 3, so we have 3 to the 3rd. We have a subtraction sign, so underneath it's going to be 9 squared. We have 16 to the 1/2. I almost made the mistake, but notice that we have a subtraction right there, sign right there, so we're going to put it in the denominator. Here we have a 6, it's positive, so it's going to go in the numerator, and we're going to put squared. That gives us log base 3. And we have 27. We have 9 squared, which is 81. 6 squared is 36. And the square root of 16 is 4. So now what we're going to do is we're going to continue to simplify this. We know that with 27 and 81, this right here would become a 1. This right here would become a 3. With 36, if we divide it, this becomes a 1. This becomes a 9. 9 divided by 3 is 3. So we have log base 3 of 3. And if you remember from the first set of notes, whenever we have bases that are the same, it's always going to equal 1. So we're looking back up here. We see the bases are the same, so our answer is 1.